Alrighty, so here we are looking at tree diagrams. This video, again, suitable for 3C grade 11 students. This is not review, this is an introduction to our tree diagrams, which really are a way to organize and keep track of our thinking when we're considering our total options or multiple events taking place. It's a method of putting down our ideas to help us count. Our prerequisite skills, we're going to rely on our previously learned terminology from probabilities, events versus outcomes. So we're working with our tree diagrams. When buying a new car, we have the following options. We can have either cloth or leather seats. We can have a 2-door, a 4-door, or a 5-door, which is a hatchback. And we can have either red or black or white or silver paint. Okay, so those are three decisions that we're going to need to make. One from our seats, one for our doors, and one for the color of the paint. And we're going to need to come up with a tree diagram that illustrates the number of total choices we could make. How many different kinds of cars could we make if we have ourselves cloth or leather seats, 2-door, 4-door, or 5-door, or red, black, white, or silver paint. So we're looking right here. This is you. You are happy because you're getting a brand new car. Now your very first decision that you're going to make is going to be either cloth or leather seats. That's two different options we could take. We can only make one of those options. Each of those options is going to be a pathway, right? So first we could either choose cloth seats or we could choose leather seats. We put both of these single option on one layer of our tree diagram. So this very first option that we have, cloth or leather seats, shows up right here. There are two branches because there are two possible options we have available to us. Now, if we get cloth seats, we're still going to need to make another decision. That is, we will need to have either 2, 4, or 5-door options. This time, that's 3 options. So we're going to put 3 branches from our cloth option, and that is we have a 2-door, we have a 4-door, or 5 doors. Great. Now, thing is though, if we choose leather seats, we also have that exact same decision to make. So again, we'll give ourselves 3 branches. That is a 2-door, a 4-door, I'll take a little shorthand here, or a 5-door options. Now again, you will notice this second decision that we are making, that is how many doors we're having, shows up all on one layer of our tree diagram. So this tree diagram right now has 2 layers because we've made 2 decisions. I'll say that again. This tree diagram has 2 layers. One layer here because we have made 2 decisions so far. Now we still have another decision to make, and that is about the color of the paint right here. So if we are making this decision from the color of our paint, we can make this decision regardless of which seats we choose, regardless of how many doors we choose. We're still going to have all 4 of these options available to us. 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Look at all of those decisions we're making. That is red, black, white, or silver. Red, black. And this was our 3rd decision that we made. This is our 3rd layer that we have. Each decision is 1 layer. Well, that's great. If each decision is 1 layer, each pathway that we could take from where we are to ending up with a certain car, let's say this is one pathway, right? We can see another pathway. Let's change our color right here. We can see another pathway right here, cloth 4 doors red. We could choose another pathway. We could say, okay, we have leather 5 doors and white. I'm not really sure what's happening here with my highlighter. There we are. But the idea is here there are so many different pathways we could take. Now the total number of different options, the number of different choices that we have here, if we're following this, is going to come exactly from this lowest level, right? This lowest layer tells us exactly how many different pathways we have, and that is we just count all of our values in this lowest level. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 23, 24 there. That tells us that there are 24 total options available to us if we're making these 3 decisions. There are 24 different kinds of cars we could put together with these options here. I'm hoping you're following the way that our tree diagram, this is called the tree diagram. You can see here how it branches out. It's like the roots of a tree underneath. Some folks like to draw this from the bottom up. I just don't have the space right here, and that's all right. Now, our tree diagrams can be used when we're working with a number of certain options to find out how many different choices we can put together. We can also work with events happening. So let's take a look right here. We have a bag of black and white marbles. There is a 50-50 chance of drawing a black or a white marble. And if we draw 3 marbles in a row, we'll create a tree diagram to find out certain probabilities. First, let's start off with our tree diagram. Here is you. You are happy because you're playing with marbles. Now, the very first event that happens is going to be you pulling 1 marble. Here we're drawing 3 marbles, but the first event is just going to be drawing 1 of those marbles. This very first marble that we draw could either be black or it could be white. There we are. That is one event that has happened here. You'll notice a difference. Last time we were talking about decisions. Now we're talking about events. This is one event that has happened. That is one layer of our tree diagram. Our next event that will happen will be our next layer. If we pull a black, now we're pulling our second marble. Okay, well, it could either be black or white. Our second marble could either be black or white. Does not matter whether we pulled a black or white for the first marble. Our second could still be either black or white. And we'll keep right on going right here. We're taking one more event that's happening. Black, white, black, white, black, white, and black, white. Now the idea here is we've had 3 events. 1, 2, 3. That gives us 3 layers. The different pathways we could take one pathway right here. We could take one pathway right here. We could take one pathway right here, one pathway right here, and we're seeing all of our different pathways available to us right here from looking at our tree diagram. I'm hoping you can see that this in general becomes a nice pattern like a tree, and I'm hoping you can see our 3 levels. That's the 3 events that have happened right here for the 8 total paths, because there are 8 total values in our 8 total pieces in this final layer of our tree diagram. Now, let's analyze some of these pathways, some of these events, right? So this very first pathway that we follow, what has happened? Well, in order to get here, we have drawn a black, and a black marble. We've drawn 3 black marbles. What about our second pathway right here? Black, black, white. Okay. Black, black, white. I'm hoping you can follow these pathways and that each one goes through 3 events that have happened right here. Here we have a black, white, black, a black, white, white. And now, if that's the case, now I'm not going to put down all of the events down here. If you would like to, you can. Let's look at the probability of drawing 3 black marbles. Well, the probability is going to come from, right? It's going to come from our number of successful outcomes divided by our total number of possible outcomes. Now in this case, we already said there are 8 total possible outcomes. So that's our denominator of our, that's the denominator of our fraction right here. And it's the numerator we're looking for. Okay, so if we're drawing 3 black marbles, how many of these pathways have 3 black marbles? Well, it cannot be any of the pathways on this side of our tree, because we notice right away there is 1 white marble that's drawn right here. So we'll have to follow 1 black marble, and then it cannot be any of these because there's a white marble down here. A second black marble is here, and then it cannot be on this side because there's a white marble. Only one of our pathways right here, only one of our pathways covers 3 black marbles, so that is the numerator of our fraction. The theoretical probability of drawing 3 black marbles in a row is 1 out of 8. Let's look at part B. Part B, we're looking at the same thing. We're going to look at the number of successful possibilities divided by our total number of possibilities. And that is, again, our denominator is 8. 8 different things could happen. Now, in how many of these pathways do we draw 2 black marbles and 1 white marble? Good, so we're looking at 2 black and 1 white. Well, that is not going to be this very first option because there's no white right here. 2 black and 1 white, that is satisfied by this pathway right here. 2 black and 1 white is also satisfied by this pathway right here. It is not satisfied over here. It is satisfied right here, 2 black and 1 white. That looks good to me. So now we have 3 different pathways that have covered it, and then these each have 2 whites in them. So we're working, that tells us that there are 3 different pathways that we could follow in order to have 2 black marbles and 1 white. That is 3 out of 8 is our theoretical probability. I'm hoping you have followed along. If you're feeling comfortable with your tree diagrams, then you should be able to handle the idea that each pathway is an event that's happening. It's a collection of different outcomes. It's a collection of different things happening that have come together to meet a certain requirement. And I'm hoping you can pull them into some theoretical probabilities. I'm also hoping you can use a tree diagram to track a total number of choices when you have multiple decisions coming into play. Nice work here.